let's practice a couple of these. So we've got a sentence that we're going to translate into a skeleton equation. Then we'll balance it. We'll write our total ionic equation and then our net ionic equation. Okay, so again, have these slides in front of you because I'm going to turn to a blank page to give this a shot. All right, so we have zinc metal reacting with aqueous copper 2 chloride to produce copper solid and aqueous zinc chloride. So there's my zinc metal, my aqueous copper 2 chloride, and it's going to produce copper solid and zinc chloride. Okay. You might recognize this at first as a single displacement reaction. Okay, so here's a... Now, let's see here. Zinc and zinc, 1 and 1. Copper, copper, 1 and 1. Chloride, I have 2 and 2. So this is already balanced. So now let's write our total ionic equation. So my zinc solid stays zinc solid. My copper 2 chloride, aqueous, we get copper 2. And we get 2 chlorides. We have our copper metal. We have our zinc. And our 2. All right, so when I look at this, all right, I've got zinc solid. And over on my other side, I have a zinc ion. So I'm going to underline those. Okay. On this side, I have a copper 2 ion. On the other side, I have copper solid. So I'm going to underline those because those change from side to side. Now my chloride, I have 2 chloride ions and 2 chloride ions. So those are exactly the same. So those, I started off with chloride ions in solution, and I ended up with chloride ions in solution. So don't have to do anything with those for the net ionic because they don't show up. So what actually reacted was our solid zinc, our copper 2 ion, giving us copper solid, and a zinc ion. Okay, so there's our net ionic equation. All right. Let's try this other one. I've got aqueous ammonium nitrate reacting with aqueous sodium hydroxide to produce aqueous sodium nitrate, ammonia gas, and water. So there's my ammonium nitrate. There's my sodium hydroxide. Okay, and I am producing sodium nitrate. Ammonia gas, and water. Okay, so when I look at this one is also nice that it's already balanced for us, so we don't have to do anything fancy here. We just leave it alone and keep on going. Okay, so now let's go ahead and break it up. So my ammonium nitrate, get an ammonium ion and a nitrate ion. My sodium hydroxide, I get a sodium ion and a hydroxide ion. And on the other side, I'm going to get a sodium ion and a nitrate ion. I'm going to get my ammonia gas and my water. Okay, so on my reactant side, I have ammonium. I don't have ammonium on my product side, so I'll underline that. Nitrate I have on both reactant and product. Sodium I have on both reactant and product. And hydroxide I only have on the reactant side. My product side, I've got my ammonia and my water. So my net ionic is ammonium ion plus hydroxide ion gives me ammonia plus water. This is a double displacement Okay. It may not look like it necessarily at first because we didn't just simply swap the ions, but one thing that we will learn as we go through the rest of this chapter is that when we get certain products, ammonium hydroxide being one of them, they are unstable and will immediately decompose into a gas. And so here, if I had swapped my ions, I would have had ammonium hydroxide and sodium nitrate, but that ammonium hydroxide immediately breaks down into that ammonia gas and water.